So the square root of n is a whole number if is the square root of n a whole number if n is a positive whole number. Another way of phrasing this question is n a perfect square? So let's take a look at the answer choices and see what it gives us. Statement 1 tells us that the square root of 9n is an integer. Remember that if you have the square root of x times y, that's equal to the square root of x times the square root of y, so we can separate those out. This is the square root of 9 times the square root of n. We know that the square root of 9 is 3, and the square root of n, since the whole thing must be an integer, the square root of 9 is an integer, and the square root of n must be an integer, which is what the question was originally asking. So 3 times the square root of n equals a positive whole number. Therefore, this statement is sufficient. It's not B, and it's not C or E. Statement 2 tells us that the square root of 6n is not an integer. So square root of 6n is the same as the square root of 6 times the square root of n. We know that the square root of 6 won't be an integer, but that doesn't tell us anything about whether the square root of n is or not. It could be an integer, in which case this whole thing would not be an integer, or it could not be an integer, in which case this whole thing would still, or might still, not be an integer. So knowing this guy is not an integer doesn't tell us anything about this, and so statement 2 is insufficient. We can eliminate D and identify A as the correct answer.